Let us now print the in-order traversal of a binary tree. So we are given a function print in-order and it accepts an argument node representing the root node of the binary tree. So here we have the function print in-order and then we have struct node pointer node. So initially it will be the root node and then we have to make use of this function and then print the in-order traversal recursively. So let us look at the struct node. So struct node we have int data which represents the value of the node and then it has two other pointers to struct node, left and right. So left pointer, it points to the immediate left and right pointer it points to the immediate right. If there are no left node then this will be null and if there is no right node then the right pointer will be null. So we have to make use of this data and print the in-order traversal. So let us look at an example. So first in-order traversal is printing the left subtree and then printing the node value and then printing the right subtree. So initially we are starting with 40 which is the root node. So let us write down the output here. So for 40 what should we print? We should print the left subtree. So we are going to left 35. So for 35 again we have to apply the same order left. So left is there. So we are going to 25. So now for 25 we have to apply the same order. We are going left. So we are going to 5. Now for 5 we are going to apply the same order left. 5 is not having any left node. So we need not proceed further. So we must print the node value then because left traversal is over for 5. Then we have to print the node value. What is the node value? It is 5. So we print 5. Then we have to print the right subtree. But there is no right node for 5. That's it. The traversal is over for 5. So we go back to 25. Now for 25, left subtree traversal is complete. So we have to print the node value. That is the second step. So we are printing 25. Then we have to print the right subtree. 25 is not having any right subtree. So the in-order traversal for 25 is complete. The control goes back to 35. Now for 35, the left subtree traversal is complete. So we have to print the node value. So 35 is printed. Then right subtree traversal. So it comes to 20. For 20, we have to apply this sequence. Left is not there, null. So we print the node value then 20. Then right subtree, it is not there. So now the in-order traversal left the node value and the right is printed. So it goes back to 35. Now for 35, all left node value and right have been traversed. So the control goes back to 40. Now for 40, the left subtree has been traversed. So we have to print the current node value because that is the second step. So 40 is printed. Then it must print the right subtree. So the control comes here to 30. Now for 30, left must be printed. So the control comes to 15. So for 15, there is no left. So the node value must be printed then. 15 is printed. Then there is no right subtree. So the control goes back to 30. Now for 30, the left subtree has been printed. So the node value must be printed. So 30 is printed. Then the control comes to the right subtree. So 10 it comes. So for 10, there is no left node. So the second step is the node value itself. So 10 is printed. Then there is no right subtree. So the control goes back to 30. Now for 30, all left node value and right subtree are printed. So the control goes back to 40. Now for 40, left node value and the right subtree, everything is printed. So because it is a root node, the control does not go back anywhere and the recursion ends. So this is the logic we need to follow in implementing this function. So now in the print in-order traversal, we have to traverse the left subtree first. So we say print in-order node left. Because left is the pointer to left node, as we see here in struct node. Then we have to print the value of the current node. So that is an integer value. So we say node data. As we can see, int data is the variable which is holding the value. So we say node of data. Then we need to print the write subtree. So we say print Inorder node write. But all these steps must be executed only when the node that is coming in is not null. So if node equal to null, then we need not proceed. So we will say return. Or as an alternative, you can put all these three within the check that node is not equal to null, but I prefer to have it this way. So this condition is called base or exit condition. Okay. So if node is null, return, don't do anything. So if the control comes to line number 6, it means the node is not null. So you pass the pointer to the left subtree, that is the immediate left node, so that recursively it will print the Inorder traversal for the left subtree. Then after that ends, you are printing the node value, and then you are recursively printing the right subtree. So now we have completed our code. Let us execute the program. So the code has passed. So based on our discussion, please solve the program, and thanks for watching.